Another important use of limits is to figure out if a function is continuous at a specific x value. The easiest way to understand this, imagine putting your pen on the graph and moving from left to right. If you can do that without lifting your pen, the function is continuous at that point. But if you have to lift your pen to keep going, the function is not continuous at that point. Let's check out an example. The first question is, will the function be continuous at x equals -2? What that's really asking me is, can I take my pen, move from left to right through -2 on the graph without having to lift my pen? As we move from left to right through x equals -2, we can see there's no problem. I didn't have to lift my pen to get past -2. So we can say the function is continuous at x equals -2. Next question, will the function be continuous at x equals 3? Let's take our pen again, move from left to right through the point x equals 3, and see, can we get past that point on the graph without having to lift our pen to keep going? The moment we try that, we can see it's not possible to move past x equals 3 on the graph without having to lift our pen. So we can say the function is not continuous at x equals 3. Now that we know how to check if a function is continuous at a point just by looking at the graph, what happens when we want to work out if a function is continuous, but they don't give us the graph? Like, for example, this question asks if the function is continuous at x equals 2, but they don't give us a sketch. Now, what we could do is go sketch the whole function and check what's happening at x equals 2. But let's be honest, that's going to take way too long and way too much effort. That's why limits are our best friend in this kind of question. We can use limits to figure it out quickly without having to sketch the whole graph. And here's how that works. The full video is only available to our awesome ebook course students. In our ebook course, all your videos live in one place, together with the ebook and downloadable cheat sheets. No more 2 a.m. doom scrolling on YouTube before a test. Everything's in one spot to help you succeed at Calculus 1 the first time. Let's be honest, I'm not here to convince you of the beauty of calculus. I'm not a professor who can talk for 3 hours about how elegant differentiation is. This is damage control to get you through Calc 1 so you can move on with your degree and with your life. This is your please don't ever make me redo this class again plan. And it's all at a student-friendly price that costs less than a mid-tier restaurant meal. Not even steakhouse level, more like a fancy burger with just one side. See you inside the ebook course.